Okay, welcome to this short introductory video on Level 1 Mechanics for NCEA Science. Um, I like to call this topic Describing Motion because that's essentially what you're doing in a variety of ways. It's for 4 credits and it's externally assessed in November. If you take any object, so let's just take a car just for instance, any object, you should be able to describe its motion using the correct physical terms and the correct formulae and graphs. So the way I like to divide this topic up is I like to look at the velocity and acceleration of the object first of all. So that involves key terms, a lot of key terms, and some graphing. So that's the first section I would spend a couple of weeks teaching. The second section I look at then would be the forces acting on the object, because if forces are unbalanced, then you get change in motion of the object. So forces are related to motion. So I would look at the forces acting upon it, things like resistance, thrust, gravity, etc. And then the third aspect we look at is the energy. The energy changes involved with the motion of the car. So the energy of the car in this case, energy of the car. And we look at particularly kinetic energy, obviously, because we'd be considering motion a lot. Potential energy if it's not moving, which is also restored energy. And then a little bit, which is related to that as well, as we would look at the power of the car or the object, power of the object, and any work done by the object. And the real central theme for this topic is a box of formulae, which you get at the start of your exam paper, and I'll refer to that box many, many times. But for today, we're just going to look at one formula, which is the velocity formula. V equals the change in distance over the change in time. I'll come back to that now in a second. So first section here, I'm just going to focus on velocity for today. And velocity is measured in meters per second. Meters per second, m times s to the minus 1. It can also be written as m/s, but for your exam papers, this is what you will see coming up again and again. So get used to using m times s to the minus 1. And velocity is defined as follows. So since the units of velocity are meters per second, the definition should involve something to do with distance and something to do with time. So simplicity's sake, definition of velocity would be the distance covered by an object per unit of time used, so per unit of time. And then technically velocity is different to speed because velocity has direction. In other words, the car is traveling north from its point of origin. But for the NCEA papers, we use the word speed or velocity interchangeably. So just be aware of that. Speed and velocity, the same thing essentially for level 1 mechanics. The formula, as I said, is up here. So velocity equals change in distance over change in time. So this is capital delta. It's just a Greek letter, and delta means change in. That means change in time on the top, and then change in distance on the top, and then change in time on the bottom. V obviously stands for velocity, so of course it can be referred to as speed. So the best thing to do now is once you have a formula is that you have to start practicing using it to answer some questions. So I'm just going to write down some questions here and then we'll try and answer them. So a fish swims 40 meters in 90 seconds. What is its speed? Now the first thing is we know that speed is obviously referring to velocity. So we'll quickly change that to velocity because we're using v there. I also like to be able to think in pictures because it really helps me understand things and hopefully some of you guys too. So you should be able to draw a picture, a little picture for every one of these questions that you come across. So we're talking about a fish here and he's just swam 40 meters. So from the point of origin to where he is now, that's 40 meters per meters. And then that took him 90 seconds altogether. That took 90 seconds. So that's your picture. That's your little picture. Now this is just a straight up calculation of velocity. So the formula for calculating velocity here, or speed of the fish, is going to be the change in distance over the change in time. Now the change in distance was from 0 to 40 meters. So that's equals to 40 meters on the top. And the change in time was from 0 to 90 seconds. So that is 90 seconds on the bottom. And that works out to be 0.444 meters per second. Now, if you notice here, I have units on every single number that I'm writing during my calculation, and also the correct units for the final answer. Make sure you do that, otherwise this answer is essentially half correct if you only put the numerical answer in. The other thing as well is I've used 3 significant figures here. For NCEA, you should always quote your final answer to 3 significant figures. So just remember that as well when you're doing your calculations. So that's probably the easiest type of calculation you could get for velocity, where they just ask you to calculate it straight up. There are a couple of variations on these questions. We'll take a look at those now as well. So what if they want you to calculate distance, which would be d, instead of velocity? So what you guys need to be able to learn to do with any of the formulae which involve just 3. So if there are just 3 things being calculated, 3 parameters, then you should be able to make a formula triangle from the original formula. Now, the formulae are given to you in a linear fashion, so like this. That's a linear fashion I would describe that as on your exam paper. You should be able to convert any one of those formulas which have 3 parameters into a formula triangle. So v would be on the bottom, the change in distance would be on the top, and then the change in time would be on the bottom as well. How do you remember that? Well, if you know the units of velocity are meters per second, then you should remember that the distance goes on the top and the time should go on the bottom. So now that we know that, we can use a formula triangle to actually work out velocity, distance, or time, depending on what the question asks of us. So if we take a question where, I'll just quickly write this down. So if the time is 10 seconds and the speed, which would be v, is 20 meters per second, what is d basically? So what distance would be covered? What would d be? Now the way you use these triangles is you want to, first of all, identify the thing that you're trying to calculate, which is d in this case. So we're trying to calculate d. So what you want to do is you want to cover the one that you're trying to calculate, and that tells you what to do. So once you cover d right there, that tells you that if you want to work out distance, change in distance, you take the velocity and you multiply it by the change in time, which is right there. And then that would simply be 20 meters per second, writing the units, by the change in time, which is 10 seconds, which then, of course, is 200 meters, because the seconds cancel out there with the reciprocal seconds, or seconds minus 1. So the final possible parameter that you could be asked to calculate would be, so time in this case, so t. So we've calculated velocity already, we've calculated distance. In this case, we're calculating time. But what if your units of distance are in kilometers and not meters? So let's just take a look at this. We take a look at the formula triangle again, which was change in distance on top, velocity times change in time on the bottom. In this case, we're trying to calculate t, so we cover t, and that tells us that the change in time will be equal to the change in distance divided by velocity. The change in distance must be in meters, because we want our final answer for time to be in seconds, and then velocity is already in meters per second. So we want the distance to be in meters. So 10 kilometers will be equal to, we got to multiply that by 1,000 to convert kilometers to meters. So it will be 10,000 and then 3 zeros meters. So 10 kilometers is 10,000 meters. And then the velocity is already given to us as 8 meters per second. So the change in time will be equal to 10,000 meters divided by 8 meters per second, which will give you an answer of 1,250 seconds. And that can be converted to minutes by dividing by 60, because it's 60 seconds in a minute. And that gives you 20.8 minutes. Answer to 3 significant figures with correct units. So they're the 3 main things that you could be asked for using the velocity formula. And then next week, we're going to focus on graphing speed. So next week, we're going to focus on graphing speed. We'll make a video next week to summarize that. Okay, so short introduction. We only did 2 lessons really this week. we continue with graphing next week.